Okay, we're on number 11. Okay, on number 11, we're going to be solving the given function, and they actually give us one of the roots. So again, make sure you print your review so you can see the questions that we're working. If I'm solving this function, and I'm given that 2 is a root, they're telling me it's one of the answers. So I'm going to start by dividing out the 2 using synthetic division. That means I'm going to need to use my little cheat so that I make sure that if there is a position missing, I do use placeholders of 0. This one doesn't have any positions missing, so I'm going to go ahead and do my synthetic division. 2 times 2 is 4. Write in the next available position, add down. 2 times 5 is 10. It's going to leave behind negative 3 when I add down. And 2 times negative 3 is negative 6, and a remainder of 0. That is not a surprise because we already knew that 2 is one of the answers we were going to need for our master list. What's left, though, is not this third-degree polynomial after you divide it off. We have a quadratic, and it's not an option. At that point, we do want to factor it, or if you're allergic to factoring, use the quadratic formula. Factors of 2x squared are 2x and x. The factors of 3 I want to use are 1 and 3. The 3 will be negative, the 1 will be positive. After I set each one of those equal to 0 and solve, I'm going to get a negative 1/2 and a positive 3. Oops. So all of those go inside the master list of 2, negative 1/2, and 3. For number 12, we're doing the same thing. Number 12, we are dividing a root of negative 1. This time I'll go ahead and just put it in. The function that we're plugging into is a third-degree polynomial, as you can see on your review that you printed. On this one, let me write the function down right above it. Function was to solve the function 3x cubed plus 3x plus 6, given that negative 1 is a root. So it is a third-degree polynomial, but it's got a coefficient of 1 on the third-degree term. There is no second-degree term, so we're going to use a placeholder of 0. The x term has a coefficient of 3, and 6 is our constant term. Now, quickly, we'll do the synthetic division from left to right. Negative 1 times 1 is negative 1. Add down. Negative 1 times negative 1 is... oh, let's see. 1, which is going to be 4, and negative 1 times 4 is negative 4, which is 2. I did something wrong. There's a typo or something here. So I'm going to omit this one. Oh, I know what I did. Sorry. Let me erase so we don't have to start all over again. Did you notice that the third-degree coefficient is not 1? The third-degree coefficient is 3. Okay, now it'll work. It is missing the squared term, though, so I was concentrating on this so hard I messed up. I apologize. Now bring the 3 down. Let's start over again. Negative 1 times 3 is negative 3. Add down. Negative 1 times negative 3 is positive 3. Add down. Negative 1 times 6 is negative 6. Add down. We got a remainder of 0, but again, it's not a surprise. We knew that negative 1 was one of the roots. They told us that. So that's the first number that goes in our master list. What's left is a second-degree polynomial, 3x squared minus 3x plus 6. Now, this has an extra 3 in common all the way across. If you don't notice it, it's okay. You can still use the quadratic formula with those numbers. But it does let me see, by dividing that 3 off, that this does not factor. So we get to use our quadratic formula with an a of 1, a b of negative 1, and a c of 2. Let's plug in. x is equal to minus whatever b is, plus or minus the square root of b squared minus 4ac, all over 2 times a. Minus a minus 1 becomes positive 1. The square root I'm going to clean up here. It's going to be 1. Negative 4 times 1 times 2 is a negative 8, which is going to give us a negative 7, all over 2. That cleans up a little more. 1 plus or minus the square root of 7, I, all over 2. And those are the last 2 zeros that we want inside our master list. Right, let's go on to number 13. Number 13 says to use the remainder theorem to evaluate this function at 5. Well, with the remainder theorem, we know that that function can be evaluated at 5 by using synthetic division. The 5 will be our divisor, and using our little cheats, I'm going to put my function in. We need a third degree term, a second degree term, a plain x term down to the constant. Our third degree coefficient is 2. Our second degree coefficient is negative 7. Our plain x coefficient is 9. And our constant term is negative 3. We're going to start by bringing the 2 down, then we're going to multiply and add down all the way across. So 117. The remainder is going to be the answer we're looking for, the value of the function. Let's do number 14 as well. We're going to be asked to evaluate this function at f of 4. Well, do synthetic division again, and using the remainder theorem, we know that the remainder theorem is telling us the remainder that you get when you evaluate this function using synthetic division is going to be our, I need my cheats on there first. We're putting a third degree polynomial function into the synthetic division box, so I'm going to put my cheats on there first. Our third degree coefficient is 4. Our second degree coefficient is non-existent, so we're going to put a 0 in. We don't have one. Our x term has a coefficient of negative 13, and our constant term is 8. We're going to bring the first number down and then multiply and add all the way across. $212 is the remainder that we get, and that is the value of the function that we're looking for. All right. I will see you in the next video.